Okay, why don't we, let me just do that quick, is everybody ready poll again. Let me know when you're ready to go, when you've got, you got your script opened and ready to go. All right, we got 75% voting yes, they're ready to go. So I'll just give it a couple more seconds here, and then we'll get going. Okay, it looks like we've asymptoted at 75% in any event, which is good enough for me. Okay, so what we're going to do today, I'm going to rewind just by a couple code chunks and basically start at the start with the very beginning of the XYplot stuff, of the lattice stuff. Okay. So I do see the question showing up there. I'll get to that. What we're going to need to do, we're not going to redo everything we did last time, but we're going to need the same data set that we used last time. So what you want to do is go back to chunk number 2 in the script and reevaluate that so that we have the same data set there again, okay? I don't think that we manipulated the data set between when we created it and chunk 14. So I think then we can jump ahead to chunk 14 and we'll start there, which means, as I said, redoing a couple things, but not too much. For those of you who didn't catch the live lecture on Tuesday and who were looking for the recording, I did just get that up just within the last hour, so that is there, and I apologize for not getting it to you sooner. If you haven't had a chance to look at it yet, then I think you'll still be fine, because again, we're going to kind of that was providing some general context and some traditional graphics functionality, and now we're going to start in on the lattice functionality. So go ahead and everybody execute this chunk number 14, which is to load the lattice package, and I'll skip chunk number 15, go to 16, and this is kind of a basic plot that we're just going to riff off of for a while. We'll just do various changes to this. So go ahead and execute it for now, chunk number 16. Okay, and you get a plot there. Let me go ahead and answer this question about what does print do. I started to try to talk about this last week. It may still, I'll explain it again, and it may still be confusing after this explanation. Really the bottom line for now is don't worry about it. If you want, you can delete that print and the closing paren and just execute the XYplot, and everything will be just fine. It's going to make the plot for you. As I said, nonetheless, I'll try to explain it. Don't worry if you don't follow this explanation completely. Basically what's happening is, and this is a difference between lattice and traditional graphics. When we call this XYplot function here, it might look like it's just directly drawing stuff on the screen, but what's kind of happening underneath the hood is it's creating an object. It's creating a plotting object. And one way to kind of get a sense of what I mean by that is I can create a new variable. I can call it x. And I can give x the value of whatever's returned by XYplot here. And when I do this, because this is an assignment statement, right? Because I've got this arrow in it. So because it's an assignment state, and let me clear this graphic that's already here. Yes. Okay, so I've got nothing in my plot window, nothing on my sleeve. So now when I execute this, my revised chunk number 16 here, it's not going to print anything, right? It's not going to plot anything. I do have an object that I just created called X, and I know somebody asked last time, what does str do? Str gives you the structure of an object. So let's look at the structure of X. And don't get intimidated here. You don't need to understand all this, but what you can really, all you want to take away from this is when I ask for the structure of X, it gives me this list of 43 things. You know, it's some really involved object with a formula and a legend and a panel and a bunch of stuff that we don't need to understand at all. The bottom line is it's got some sort of code-based representation of this plot. That's not the plot itself. We don't get the plot itself until we evaluate X at the command line. So I could say X, and now it's going to print it. It's going to plot it. And the reason, well, the mechanics of how it gets plotted there is when you just type the name of a variable, it could be, you know, I'll make another variable here, y is 2, okay? You can just type the name of the variable, or you can explicitly say print and then the name of the variable, and usually it'll give you the same thing. I'm sorry, always it'll give you the same thing. Because when you just evaluate a variable at the command line, really that is actually shorthand for print X. If I just say X, that's shorthand for print X. So again, I could clear this, and now I could print it. And it's the same as just typing X, and it's going to print it. Okay. So that might seem all kind of silly. Where it starts to matter, and I mentioned this last time, is when you're doing things in a scripted fashion. So right now, and actually throughout this course, we're going to always be running R interactively. And when you run R interactively, just typing X, again, is synonymous with typing print X. But when you're doing things in a scripted mode, which running R in what's called running R in batch mode, the output is handled differently. And so in that case, if you want something to be shown, if you want a value to be shown, you have to explicitly ask for it to be printed to the output. And if you want a plot to be created, then you have to explicitly say print. So that's only going to apply when we run R in batch mode, which, again, we're not going to do in this course. At least I don't cover that. I can't remember if Tim may cover that or Bill in one of their lessons. But so anyway, hopefully that explanation. I don't want to spend any more time on that. Hopefully that explanation may have helped. That's what print is all about, though. Okay. But again, for your purposes now, if you want to get rid of all those print statements, fine. Not a problem. Okay? All right, so what we saw already was, in chunk number 16, we just made this single panel plot. And as I started to talk about at the end of last time, what's great about Lattice is it makes it very easy to go from a single panel plot to a multi-panel plot. We're just going to add this conditioning piece here. So we're going to use bar to represent the pipe, vertical bar to represent conditioning. And then our conditioning variable is going to be month. And now we're going to get a different panel for each month. So that's great. Now, what we're going to do for the next few code chunks here is we're going to start, increasingly dressing this up, doing a few things that that you might want to do if you're going to, make it a plot for other people to look, or even for yourself to look at, just to kind of both to pretty it up and to make it maybe a little bit more informative. So the first thing we're going to do is we're going to change the layout of the panels. So what Lattice is generally going to do is, in this case we had 4 months, and so it just says, all right, well, I got to fit these panels into a square. I know how to factorize 4. I can factorize it as 2 by 2, so I'm going to do it as a 2 by 2 grid. And it's just got an algorithm that kind of looks at the general plotting area that's available and figures out a factorization that's going to make sense for the amount of plotting space that you have. But we may not want that, right? So, in particular, if you're interested in really kind of comparing from one month to the next how the Y values change, then it would probably make more sense to have the layout be just one long strip, put all the panels side by side. So the one difference I'm making now is I'm adding an additional argument called layout, and I'm saying I want it to be 4 columns by 1 row. And otherwise the plotting statements are the same here. So we'll run that, and if I stretch that out a bit, that's probably a more informative view of the data. At the very least, it's more informative with respect to variation in the response across months, right? So that's layout. That's a very important argument that you'll want to be able to fiddle with. Now the next thing that I'm going to show in trying to pretty this up is this is a question that was asked toward the end of last class. You may look at the way that month is represented here and say, I understand what that means. It's the orange bar is progressing from left to right, but it's kind of not helpful so much, and that a lot of people are going to look at this and say, what does that mean? So it'd be nicer maybe to have the label actually say, month 1, month 2, or whatever. So what has happened here is there's a couple. These are, first of all, these orange text areas at the top of each panel. They're called the strips. And Lattice has, I think, really just 2 different ways of handling. Well, basically 2 different ways of handling the strips. One is when it encounters a variable that it thinks is a numeric variable, it's going to do this thing where it's got a dark orange band that moves across according to how much the conditioning variable changes. Let me take a look at this question here. I could not see plot generated in RStudio, although it seems running okay in console. If you don't see the plot generated in RStudio, and this may happen to other people through periodically, probably what has happened is you may have opened up another device. Remember we were playing around with those PDF devices? At the very least, since that's a possible explanation, just to be safe, try doing graphics.off. That's going to turn off all the open graphics devices. including the one that was on the screen, but it will also turn off any PDF devices that you opened. And then try it again. And that may fix the problem. If that doesn't fix the problem, I really don't know, but feel free to follow up with me offline and we can try to figure it out. Okay, so as I said, so this panel style that we have here is a consequence of the fact that if we look at this, let's use this str function again. Let's figure out what's the structure of the month variable within the DataFrame DAT. So if we run that, structure tells you a few different things. Number one, it'll give you the values of the variable. It won't give you all of them because it wants to give you sort of concise output, but it'll give you the first few values, and then it'll just say ... so that you know that there are more that it's not printing. It'll tell you how they're indexed, so these are indexed from 1 to 160. And the part that we care about right now is that it is telling you that it sees this as a numeric variable. That's the NUM. So we can skip over chunk 20 and go to chunk 21. Let's see. Yeah, no, actually, I take it back. Let's do chunk 20. So I have it commented out. I forget why I commented it out. But, and now I usually like to use Emacs or Aquamax as my editor. And that has a way of removing these comments. I don't know in RStudio if there's a convenient way of just removing the comments. Here we go. All right. There's well, on a Mac it's Command/, but in any event, you have should have a menu item there that will. Yeah, I don't know what the Command key is mapped to if you're working on a non-Mac environment, but you can always just select that. So I'm going to uncomment those lines. I guess I got to do it twice because I got two comment characters. And now we're going to do this kind of piece by piece, and then and in the next code chunk we'll see a shorthand way of doing it. So what I can do is I can create another variable within the DAT data frame, and I'll just call it month 2. And so month 2 is going to be basically have the same information as month, but I'm going to take that numeric value that's in month and I'm going to paste it together with the string month. Okay? So let me just evaluate that little chunk on its own. So you can see what that's doing. So, well, actually, let's do this first. So dat month is indeed, just a bunch of numbers. If I paste it together with the string month, it's kind of concatenating the string with the numeric value. And now I'm assigning, I'm creating a new variable in the data frame that has those character values with this line here. And so I can look at the structure of that. And now, you see those sample values. You see that it's still going from 1 to 160. And the important part is now it's character. So because that's character, Lattice is going to use a different style of strips. And if you just evaluate this, and again, now we're conditioning on month 2, not on month. If you evaluate this, and you look up here, you can see that we have something that's more like probably what we want. Maybe you don't want it to say month every time. That's fine. Just get rid of month here. You could do that. Paste in that case is basically just another way of saying make this a character vector. So we could have done that. And then it would have come out looking like that. Okay? We also could have just said as character. Does the same thing. Okay? So that's the different strip styles. What I wanted to show you here in chunk number 21 is that thing that I just did of creating a new variable, month 2, and then working with that, that's fine, and that's often people are more comfortable working that way. But you can also, if you don't like to create a lot of kind of extraneous variables in your data frame, you can do that pasting on the fly. So that's what I did here. See, now here's my conditioning part of my formula. And rather than conditioning on month, I'm conditioning on this whole expression. This is going to be evaluated before it's used. And so this is kind of just a shorthand way of what we did doing what we did in the previous chunk. Okay, but it gives you the same results. Okay, how it shows 0, 3, 6, 9, why not month 1, 2, 3, 4? Well, because the values were 0, 3, 6, and 9. When we look at, if we look at the value of dat month 2, those are, the values in there are 0, 3, 6, or 9. Okay? And the other question here, if you have 1 and 11, yeah, okay, this, I think I know where this question's going. Yeah, as soon as you get to double-digit numbers, the ordering's going to get messed up. That's a very practical problem, and we come across that all the time. I'll show you how to handle that very soon, if not even, yeah, in fact, that's a good lead into the next few code chunks here. So so this is Jeffrey's question here. Let's suppose now we're going to try to do something basically similar to what we did in the last plots. You know, it's similar in the sense of we still got a y variable, we've got an x variable, we're conditioning on something, but now we're going to condition on dose instead of month. So let's try that. And that kind of works, but to Jeffrey's point here, you probably don't want the panels in this order, right? Because it's going 0, 10, 100, 30. And what's happening is that you know, most likely you would like these to be sorted numerically, but instead they're getting sorted lexically because now these are being treated as strings. So the correct way to sort these strings, like if they were entries in a dictionary, is the way that they are sorted here. So it's correct in that sense, but it's not what we want. So let me show you. I'm going to show you. There's an easy way to do this and a hard way to do this. And I'm actually going to show you the hard way, only because I think you'll learn a little bit more. And then we can go back and I'll show you the easy way too. Or actually, I'm not sure if I even show you the easy way, but I will at least refer you to an easier way. So let's try to take this one step at a time and do what we did last time. We're going to create a new variable here. So dose, the dose variable, if we look at the structure of that, That's numeric, right? If we create a new variable dose2, that's a character version of that. You know what that's going to look like. Okay. I'm sorry. Yeah. Dose2. Okay. And now, just for kicks, since we're doing this anyway, we've already made a character vector. We might want to change 0 milligrams to placebo, assuming that those guys did get some placebo pill. So let's go ahead and do that. And that, by the way, I just slow me down if I forget to mention something. So the logic here, we did something similar to this last time. The way this works is I'm using a subscripted assignment here. So this is saying I want to find all the places where dose 2 is equal to this string, 0 milligrams. And what I would recommend anytime you're trying to figure any of this stuff out, kind of work from the inside out. So you can take little snippets and, instead of evaluating the whole expression, maybe first you just evaluate dose 2 and see what that is. Next you can evaluate this whole thing here. And what this is it's going to give us a logical vector. If I copy and paste that part down here. This is going to give us a logical vector that's going to be true everywhere that dose 2 is 0. And it's going to be false everywhere that dose 2 is not 0. Now, I already, let me go back here and see, it's false everywhere for me because I already changed 0 milligrams to placebo. So let me recreate dose 2. Let me backstep a second. So all right, I got my original dose 2, and now if I look at what this vector is here, this is the logical vector that tells me where dose 2 is 0, and in those places it's going to be true, and everywhere else it's going to be false. So now that I've got that vector of trues and falses, I can say, okay, everywhere where that's true, change the value to placebo. Okay? So that's what's happening here in chunk 24. I'm just changing that to placebo. And now we're going to do something. We're going to introduce a new concept. I think Bill may have mentioned the concept of factors in the first or second class, but I don't think he went into it very much. We're gonna, instead of working with dose as a character vector, we're gonna make it what's called a factor. So right now it's character, CHR. We're gonna turn it into a factor. I'll tell you what that means in a minute. Let's look at the structure again though. Okay, so now, rather than being a character, it's saying it's a factor with 4 levels, and it's telling me what the first few levels are. So it's saying one of the levels is 10, one of the levels is 100, and then ... There's other levels that I'm not mentioning. And now you notice, instead of giving you, these are actually the sample values of the variable, and they're not those strings, they're integers. And so the way a factor works is it basically codes everything as an integer, kind of under the hood, everything's coded as an integer, and then it knows that, when something's coded as a 1, the label that's associated with that is 10 milligrams. When something's labeled as a 2, the label that goes with that is 100 milligrams, and so forth. One thing about factors that's different from a character vector is that those what I just called labels are really what's called the levels. It has levels that you can extract. So if I just say levels of dose 2, it's going to give me these values. And the order here is important. The order that you see when you say levels is the same order that you're going to get when you make the lattice plot. Now we can change that, but by default, the order that you get here is the order that's going to be used in plotting. It's also the order that's going to be used in modeling. So the basic thing I'm trying to get across is factors have levels and levels have an order. Okay? So we can change that order, and let's think about what we want the order to be. Okay? So there's a lot going on in this next chunk here. So again, let's break it down bit by bit. Let's just evaluate the inside here. What I did was I just created a vector of integers here, 4, 1, 3, 2. So I think you saw last time C is just used to collect. You just think of C as standing for collect. It collects elements into a vector. So if I just evaluated this part, it would give me the vector of integers 4, 1, 3, 2. And now because I'm using that as a subscript, that's what the square brackets imply, that's saying, well, actually let me back up a second. Let's evaluate this other part of the expression too. Okay? So, we already did this. So you know what the levels are. The levels are right here. And now when I use this 4, 1, 3, 2 as my subscripting vector, what that means is I want to put the fourth one first, then the first one, then the third one, and then the second one. Okay? So if I use, so let's evaluate that, and you'll see that using that 4, 1, 3, 2 as my subscripting vector, that's basically just going to permute everything to put it in the order that I probably want. All right. So that's fine. I've kind of got that vector as output. But what I really want to do is take this order and make that sort of internalize that into the factor structure of dose 2. So what I'm going to do is I'm going to go down to chunk number 28 now. Let's take that vector that we just created, this vector of values here. We're gonna assign that to a new object. We'll call it new levs for the new levels. Okay. So new levs is the same thing we just created. And now what I can do is I can say take the dose2 vector and basically I'm reassigning it here because dose2 already exists, but I'm going to assign a new value, and the new value that I'm going to give to it is a factor version of dose2. So I still want it to be a factor, but now I'm going to explicitly tell it what I want it to use as levels, and that includes telling it what order I want things in. Okay, so new levs is in the right order. So when I do it like this, and now I go and say, all right, tell me what the levels of dose2 are. Okay, now dose2 is still a factor, but now the levels are in order. So put all that together. Now go back to lattice. Now that dose2 has levels in the right order, try it again, and now you get a plot where things are in the right order. Okay. Now, and by the way, I guess I didn't say this. I didn't say this explicitly. If you think about it, maybe you realized it already. But even back up here, if I scroll back to chunk number 22, I was using back here, this pasting dose with milligram. This resulted in a character vector, not a factor vector. But what Lattice will do, if your conditioning variable, or actually if any variable is character, underneath the hood, Lattice is going to convert it to a factor variable. So what happened when we did this chunk number 22 back here was, let me run it again just to remind you. The reason we got the wrong order here was this thing was a character vector. Underneath the hood, Lattice converted it to a factor. And when it converted it to a factor, it put things in, it gave the levels the default ordering, which since this expression here was a character vector, when Lattice made a factor out of it, it used lexical sorting to order the factor levels because that's just the right way to sort character values. So we had to kind of undo that, okay? All right, so this is what I mean when I say that, you try to learn plotting and you end up learning a lot of other stuff along the way that's related. So even though this is mainly oriented around plotting, we've used it as an opportunity to learn about factor levels, and that's not just important for plotting, that's an important general concept to understand, is how to manipulate factor levels and to understand that has consequences. Now I'll show you one easier way that we could have done this. If I didn't want to muck around with all those, creating a new factor variable and changing its levels, there is an argument to XYplot called index.cond, because conditioning index, which basically you can give it a vector, and that's going to be a permutation vector. So first let me comment this out. Evaluate this just to remind ourselves what we would have had by default. Okay, so we would have had this by default, where lower left is the first. So this is the way if you've got things in a rectangular grid, Lattice is always going to start at the lower left corner, which from a plotting perspective, that kind of makes sense because that's where you put the origin. The point 0, 0 is in the lower left too. And so it uses the same logic that it uses within panels, it also uses between panels. So the first place is going to be down here, lower left. That's the first panel. The second panel was lower right. The third was upper left, and then the fourth was upper right. If you want to change that order around, you can use this index.cond thing to permute things. And it's saying, this is going to say, give me the first one. Basically I want to permute the last two. I want to put the third one where the fourth is and put the fourth one where the third is. So I could have done this. And again, this is easier, but this doesn't really give you any insight into how Lattice is, why Lattice is doing the funny thing that it did in the first place. So you could do it either way. It's up to you, but I wanted to show you the long way. There's another option too, which I refer to in the text, and I'm not going to show it to you, but it's a useful function to know about. Let's see. Yeah, on page 33, I say, if you find yourself doing this sort of thing a lot, you should take a look at the mixed sort function in package G tools. and also the reorder function. Reorder is actually the one that you really care about. So here's what you do. If you find yourself doing this a lot, and you probably do if you work with data that has dose, you want to go to CRAN. I think Bill showed you where CRAN is, right? You can download the package gdata. I don't know. I'm not sure if we have it here on the server. Let me see. We do. Okay, great. And gdata has a function in it called reorder. And so anytime you've got a factor, let's see, did we? Yeah, so dose2 is a factor, and we've already got dose2 factor levels sorted the right way. But let me go back and undo the progress that we made. So I'm going to go back to chunks 23, 24, and 25. I'm going to reevaluate those. So this is going to give me back the version of dose2 that has the levels out of order. Okay. Since I just loaded the gdata package, I can use the a function that's in gdata called reorder, and I can just apply that to dose2, and now I can say, tell me what the levels are once I do that reordering. And that got us closer. So it at least took care of, getting these ones where it's the mixed numerical and lexical sorting. It handled those correctly. Now it still didn't put placebo where you might have wanted it. So sometimes even if you use reorder, you might have to do some manual reordering of the factor levels. But still, that reorder function in gdata is handy. It's worth talking about now. So I've shown you a few different arguments to XYplot. And if you're saying, well, okay, that's fine, but you're just feeding them to me one by one, how do I go about this more comprehensively? Well, if you look in the help, and you search on XYplot, again, I talked about this last time, you often get more than what you really want, but the way to look through this output is this entry here is telling you about the XYplot function that's in the lattice package. So that's the one that we want to click on. And as you look at this documentation for XYplot, it's a bit intimidating because there's quite a few arguments here, and it's not so much that, but it's the number, the length of the explanation of each of these arguments is kind of overbearing. So it's a lot to throw at you at once, but you don't have to read it all at once. Here's what you do. Let's say we're looking for something that has to do with the key, the legend or the key. Well, we can just look through the argument names are the ones that are over here. So here's an argument called X, data. You just look for something that sounds like it's related to what you want. And you might not have caught this, but key is kind of another word for legend in a sense. So now you could read this about how to use the key. I read this now and it all makes perfect sense to me. I know it's kind of it might seem a little bit abstract as you go at it the first time, but go ahead and try reading this. If that doesn't help you, or if that only gives you kind of limited help, you want to realize also that at the end of most good help files, there are examples. Okay, so you could try to find an example down here. I don't know if there is one actually, where somebody used AutoKey. And here's an example right here. Okay, so you can try to run this code that's down here, and that gives you a sense of how it's going to work. Let's see what this question is. Is there a way to get x and y axis for each small plot? Okay, yep, good. Yes, there is, and I'll get to that. I forget if I get to that today or in our next plotting section. Yeah, I wasn't initially going to cover that today. I'll just give you a quick preview, and we're going to revisit this in our chapter on advanced plotting. But let's see, what's the plot we're working with right now? Should we work with? We could do this one. Okay. So I'm on chunk number 30. So the question is, if I wanted to get individualized x and y axes, how do I do that? What you can do is, there's actually a lot of options here. I'll just show you kind of a quick way. There's an argument that we're going to talk about more in depth, as I said, in the next chapter on plotting, but it's called scales. And scales governs a lot of things. Oops, I'm doing it wrong here. So scales, you give scales a list of things that you want to be manipulated. One of them can be relation. And if I say relation, by default, the relation is something called same, which means same x and y axis labels for every panel. I'm sorry, same x axis and y axis kind of dimensions for every panel. And before I show you how to override that, let's pause for 1 second and realize that's often a very attractive feature of lattice, is the fact that it allows you to use a common set of axes for multiple plots. That's really the difference, in a sense, between a lattice or a trellis plot and just a bunch of plots. Okay, so it's often very helpful to have the same x-axis and y-axis in all the panels, but it all depends on which part of the story you're trying to tell. So let's say, for whatever reason, you do want different x and y axes. You can change the relation to free, and then it will compute them differently for in each subset. So there's advantages and disadvantages to each. I mean, the advantage to doing it this way is you can understand the within panel variation a lot better. The downside of doing it this way is the between panel differences are lost because you don't have a fixed frame of reference, so you can't easily make comparisons between panels. So again, it depends what you are trying to do there. But again, that's just a quick preview. I'll have more to say about scales in advanced plotting. What's next here? Okay, this is the last important concept I want to cover in chapter 2, and the concept is the groups argument. So far, if you think about it, we've basically got a way of representing 3 dimensions. So one dimension is the x in the x-axis, one dimension is the y-axis, one dimension is the paneling or the conditioning dimension. Now let's add a 4th dimension by using the groups argument. And what that does is it's going to use, if I say groups equals subject, it's going to use either color or point, what do we call it? Glyph is the technical term, but point, the type, whether it's a circle or a triangle or a square, or line type. It's going to use something like that to distinguish between different subjects. So by default here, why didn't it do anything? Let's try that again. Oh, I never ran it. Okay. So when I say groups equals subject, because again, this is longitudinal data, so it's the same subject, whose data is showing up at month 0 and month 3 and so forth. And so now the subject level information is encoded here with color. And there's other ways, I'll show you some other ways of encoding that as well in a second. But before I even get to that, the other thing to realize about groups is it's not just a matter of encoding the subject information as color, but if I change it to type equals L, which means use lines rather than points, it knows about the grouping. So it kind of it's going to link points that are from the same subject, and it's not going to link points that are from different subjects. Okay? Or as I said in the comments here, if you want to change the L to B, that means give me both points and lines. Now in this case, you probably want to go in one of 2 directions. The first is, if we're going to use color to distinguish these patients, then we probably need a legend to say which patient is which, or which color goes with which patient. Or if we're not going to do that, if we don't really care, if we just wanted to visually link them with lines, but we don't care which patient is which, then we probably it wouldn't make sense to keep color there. So we can add an argument COL equals black, and that's just going to make everybody be represented with a black line. Now I think I've got an example. Yeah. So that's one route to go, is don't even try to map color to color or line type or whatever to the variable values. But often you do want to know what the association is between color and whatever the grouping variable is. So we'll see an example of that here in if we do chunk number 34. Now I'm going to use dose as my grouping variable. Okay. So response is still my y variable, exposure is still my x, month is still my conditioning variable, but now I'm switching over to dose as my grouping variable. So that means color and so forth is going to represent dose. Okay. So that seems reasonable, but here, especially since I've only got 4 dose levels, it's going to make sense for me to have a legend or a key. And one way to do that is the simplest way, if you're okay with the defaults, is just to say auto key equals true. So we add that argument in, and I usually don't like this default, but it's just, you know, it's putting the legend up top here. If you go, let's go back actually and look at the help on AutoKey. So within this, again, we're on the help page for XYplot, right? If we scroll down here and we look for AutoKey, we're going to say, okay, let's just try to parse this a little bit. AutoKey is a logical, which is like when I said AutoKey equals true, or a list of parameters that would be valid arguments to simple key. So now we'd have to go and look at simple key, and I guess given the time, given that we're running out of time, I won't try to read through this for you, but it's a list. Basically, the bottom line is you don't have to just say AutoKey equals true or AutoKey equals false. You can give it a list of extra arguments. So this is saying I want the title of the legend to be dose. I want to put the legend on the bottom. I want the legend to be in 4 columns instead of 1, and I want to draw a box around it. Yeah, I'm seeing the order. The question: do the order of arguments, are they important? They're not, because this is a named. This is a name value type list. So every element in this list is named. So you know, title is the name of this first element. Space is the name of this second element, and so forth. So because they're named, the order does not matter. Okay. Oh, and okay, this is good. So actually, I was planning on talking about relation, and I do get to that down here. And yeah, we got, oh, for XYplot in general. I think Tim is going to cover this in more detail, but let me try to address it now. In general, when you call any function, XYplot or whatever, it's kind of a mixed paradigm. So the safest thing to always do, where you just can't go wrong at all, is to provide names to all the arguments. And if you do that, then the order doesn't matter. So let me show you an example way back. If I go back to this chunk number 5, okay? The plot function. We gave it 2 unnamed arguments. One was called, well, sorry, neither was called anything. One was given the exposure value, and one was given a response. And when we did that, it just naturally interpreted the first argument as the x variable and the second as the y variable. And that's what's called positional matching. It's figuring out the role that each of those should play based on the order that you supply them. But if it'll also do matching by names, and we can reverse. You know, we can say, actually, this first variable, I want that to be the y variable, and the second one I want to be the x variable. And now, because I'm naming them, hopefully this won't prove me wrong. I think this should work. Yep. So the name-based matching sort of always takes precedence. But if you don't use names, it will use positional matching. And so the order of the arguments that you give has to line up with the order of arguments in here. So x is the first in the help file. X is the first argument, data is the second, and so forth. So if you're just giving them in order and not naming them, then you have to follow the order that's listed here. But if you name them, you don't have to worry about it. And then there's kind of a mixed paradigm that we often use, and the rules, I kind of have an intuitive sense of how it works. I don't think I'll try to explain the rules. I probably would get it wrong. But you can kind of do a little of both. Okay. Usually the first, one or two arguments I don't end up naming, and then everything after that I name because I don't remember the order. Okay. All right, we're out of time here. Let me just see what else we were going to cover. I think you can probably, I already said something about scales, so that's good. You could play around with chunk number 38 and 39. That'll give you a sense of what some of the other options are for specifying relations. That's also talked about in the book. And I think that's good enough for now. I didn't have time to cover the homework problems that we did last time, so I'll post a quick R script that provides solutions to that. And I'll just hang on the line for another minute or two if there's a couple of last-minute follow-up questions, but that's all in terms of, if you need to get going, go ahead. And thanks, and I'll see you in, I think 3 weeks maybe. I think you have Tim Bergsman next week. So that's it for today. Thanks. Okay, so let me get to some of these questions. How to get rid of the frame line of the legend. That was this border, okay? You could either set border to false, or I think the default is false. So if you just got rid of this altogether, I think that would do it for you. Yep. How to have separate X and Y scale for each individual plots, but of the same range. Okay, that's a great question. And that is, there's an example of that, sort of, here. So, there's basically three types of relation you can have. One is same, which means that's all the same for in every panel. One is free, which means it's computed separately for each panel. And one is sliced, which means it's computed separately for each panel, but they need to each take up, they need to each have the same difference between the maximum and the minimum. So if you evaluate this chunk number 39 here, you'll maybe be able to see, because I said y equals, so scales is now, it's a nested list. Within this scales list, there's two lists within it. One is an X list and one is a Y list. And so that basically the bottom line here is this is a way of saying make the Y scales be sliced. And what that means is that the difference, again, between the maximum value, like let's look at this first panel. The maximum value is about 60. The minimum is about minus 20. So that's spanning a range of 80. And every one of these panels will span a range of 80. But it'll just be a different 80. It's spanning different values, but the same range. So hopefully that answers that question. Oh, cannot hear. I'm sorry. Okay, I think I'm going to close up the recording, but Yvonne, let me see if I can adjust the volume and help you out there. Okay, that's the end for those who are listening to this being recorded. Bye now.